Lesson: Social impacts of AI in data analytics. The integration of artificial intelligence in data analytics has precipitated a myriad of social impacts that professionals must navigate with precision. As AI becomes a cornerstone of data analytics, its deployment in various industries has stirred ethical considerations, demanding a robust understanding of how to address these challenges effectively. This lesson aims to provide actionable insights, practical tools, frameworks, and step-by-step applications to enhance proficiency in handling the social impacts of AI in data analytics. One of the critical social impacts of AI in data analytics is the potential for bias and discrimination. AI systems learn from data that may contain historical biases, leading to outcomes that perpetuate inequality. For example, a study by Obermeyer et al. Revealed that an algorithm used in healthcare inadvertently favored white patients over black patients due to biased data inputs. To mitigate such issues, professionals can employ fairness-aware machine learning frameworks, which are designed to detect and reduce bias in AI models. Tools like IBM's AI Fairness 360 offer a comprehensive suite of metrics and algorithms to assess and mitigate bias, providing detailed reports that help identify and address unfair treatment. Another significant social impact is privacy concerns. As AI systems increasingly utilize vast amounts of personal data, the risk of data breaches and unauthorized access heightens. The implementation of privacy-preserving techniques, such as differential privacy, can safeguard individual data. Differential privacy introduces noise into the data analysis process, ensuring that the privacy of individuals is maintained even in large datasets. Practical tools like Google's TensorFlow Privacy offer frameworks to incorporate differential privacy into machine learning models, providing a step-by-step application that ensures compliance with privacy standards while maintaining data utility. The transparency and explainability of AI models also pose social challenges. Complex AI models, particularly deep learning algorithms, often function as black boxes, making it difficult for users to understand how decisions are made. This opacity can erode trust and lead to resistance in AI adoption. To address this, professionals can utilize explainable AI frameworks, which aim to make AI systems more interpretable and transparent. Tools like LIME provide visual explanations of model predictions, enabling users to comprehend the reasoning behind AI decisions and fostering trust. The deployment of AI in data analytics also impacts job markets, leading to concerns about job displacement. While AI can automate repetitive tasks, it simultaneously creates opportunities for new roles that require advanced analytical skills. A report by the World Economic Forum suggests that AI could displace 75 million jobs but create 133 million new roles by 2022. To prepare the workforce for this transition, professionals can leverage upskilling and reskilling programs. Online platforms like Coursera and edX offer specialized AI and data analytics courses that equip individuals with the necessary skills to thrive in an AI-driven economy. AI's role in amplifying social inequalities is another area of concern. The digital divide disparities in access to technology between different demographic groups can exacerbate existing inequalities when AI solutions are not equally accessible. For instance, a study conducted by the Pew Research Center found significant gaps in technology access between urban and rural communities. To bridge this divide, organizations can adopt inclusive design principles in AI development. This involves considering diverse user needs and contexts to ensure AI systems are accessible and beneficial to all segments of society. Microsoft's Inclusive Design Toolkit provides practical guidelines and resources to create AI solutions that cater to a wide range of users, promoting equity and inclusion. Ethical AI deployment requires rigorous governance frameworks that guide the development and implementation of AI systems. Establishing clear ethical guidelines and codes of conduct can help organizations navigate the moral dilemmas that arise from AI use. The IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems offers comprehensive ethical guidelines that organizations can adopt to ensure responsible AI practices. These guidelines emphasize accountability, transparency, and fairness, providing a robust framework for ethical decision-making in AI deployment. In conclusion, The social impacts of AI in data analytics are multifaceted and necessitate a proactive approach to address ethical considerations effectively. By leveraging practical tools like AI Fairness 360, TensorFlow Privacy, and Lime, professionals can mitigate bias, enhance privacy, and improve transparency in AI systems. Furthermore, investing in upskilling programs and inclusive design practices can help bridge the digital divide and prepare the workforce for the evolving job market. Adopting ethical guidelines and governance frameworks ensures that AI deployment aligns with societal values and promotes trust and accountability. By integrating these strategies, professionals can harness the potential of AI in data analytics while minimizing its adverse social impacts.